Now we're going to break down the steps that we're going to be taking in this module to accomplish the goals that we had just talked about. So we're going to start off here by getting input from the keyboard and touch. So if the user uses their keyboard to control the game, if they're playing from a web browser, for example, then we want to grab keyboard input. And then if they're using a mobile device, we want to get input from touch on the screen, which we're going to have a little UI on the screen that Quintus provides for us that'll make this part pretty easy. Once we've figured out how to get keyboard and touch input, we've enabled that in our game, then we're going to move on to make it so that the player will move based on that input. So we want to basically make the player move left or right, and we're going to adjust the position of the player based on what key is pressed or what movement command is currently activated for that player. Then, once we have the movement working, we need to make sure that the player stays in bounds of the game. We don't want the player to be able to go all the way out of bounds, so we'll implement a little bit of bounding there, just like we had done in the previous module where we had created our html5 game from scratch. And then after that, we're going to actually convert our game from a game loop to use something in Quintus called screens. Now, there'll still be a game loop internally, but we're going to be using screens to make things a little bit easier and to work more like a game, so we can think about having a special screen for different stages that we can set the stage for. And we'll talk about more about that when we actually do this conversion, but it's going to make things a little bit easier for us from that point on. After that, we're going to start working on trying to make it so that a player can shoot. So we're going to start off by creating a shot sprite. We'll need a special sprite for each shot. Once we have our shot, we're going to make a gun that can shoot, and we're going to build this as a component. Now, a component in Quintus, we'll talk about this a little bit more later, but a component is basically going to add some capability to a sprite. It's a real useful way of compartmentalizing certain behavior and applying it to an entity in our game. Once we have our shot, we have our gun, we're going to make it so that our gun can actually fire shots. And then once we're able to fire shots, we're going to need to manage those shots and also clear any old shots out. If we just let the player continue to fire shots, we'd eventually run out of memory. We'd have a lot of shots that we'd be managing. So when shots go off the screen, we'll have to come up with a good way of identifying that condition and then cleaning up those old shots. And then finally, we're going to implement some throttling. Without throttling, a player could just shoot rapidly as they want to, and we really don't want to have that capability in our game. We want to make things a little bit more challenging, so we're going to figure out a way to make it so that a player can only shoot every so many number of seconds. So the first thing that we're going to need to do is to be able to get inputs, and this is actually pretty easy to do in Quintus. What we need to do is basically include a module for input and one for touch, and what this will do is it will give us the capability to, first of all, display some touch controls on the screen, which will map to commands. We're going to have commands for things like left, right, up, and down, and Quintus automatically maps those properly for us, and then we can check to see what command is currently active, if there is a left button being pressed, or right, or up, or down, or fire, and we can just check this inside of our sprite. We're going to be adding a part of our sprite called step, and this is something that gets called every single time that the sprite gets updated in the loop. This will give us the capability to check to see if the left or right button is being pressed, and then we'll be able to do some movement based on that. So let's go ahead and get into the code and see how we can add the capability for getting input in our game. Okay, I've got our project back open, and what we're going to add now is the capability to get input from the keyboard and then also from touch. So for now, we're just going to be handling keyboard. So what we're going to do is we're going to add to our include input module and then the touch module. And like I said, we can't quite get touch just yet until we convert over to stages, but we will be able to get input from the keyboard. So what we're going to do is we're going to test this out. We're just going to say if q.inputs, and then we're going to look for left. If we have left, then what we're going to do is we're going to do a console.log, and we're going to log left. And then we're going to do the same thing for right. And we will log right. Now, you might have noticed that we're using left and right here, not an actual key from the keyboard. And that's because the Quintus input module automatically maps things for us, so we can think in terms of commands. There's commands like left, down, up, right, and fire that we can use to basically respond, so we aren't tied to a particular key on the keyboard like we were when we had implemented this ourselves. So then one last thing we have to do before we can get this working is we just have to go in here, and then under our setup, we're going to add this controls, which is going to set up our controls and let us get our input. So let's go ahead and save this, and we will take a quick look at our application now. So I'm just going to bring this over, and we're going to open up the console. And what you'll see here now is if I click on the screen and I hit left or right keys on the keyboard, it's detecting the left and right. So now we can actually use this in our game to actually move our player around. We'll just have to figure out on every iteration of the loop if the left or right button has been pressed, and if it has, we'll move in the corresponding direction. Okay, so now let's go ahead and make it so that a player can move around. So what we're going to do is let's get rid of our debugs here, these console messages, and instead what we want to do is we want to add some capability for the player to be able to detect input on every update, every time that our game loop goes through that update. Remember, we're doing this player update. Here, we want to give the player a chance to check to see if the left or right button's pressed, and then to go ahead and move if it is. So in order to do that, what we basically need to do is add a step function on here. So we're going to say step is equal to function, and here we're going to take in dt. This is the amount of time that's passed since the last time this was called. We can use this to do some calculations when we try to move around if we had some kind of speed. But in our case, we're just going to do things in a really, really simple way. What we're going to do is we're just going to check here inside this step, and we're going to say check Q inputs, and we're going to look for left. And if we have a left, then we're basically just going to do this.p.x minus equal this.p.speed. Remember that we had declared this speed up here of 10. So we're basically going to subtract whatever our speed is from our player, so they'll end up moving to the left. Then we can do the same thing for right. So we'll say if q.inputs right, then we're going to do this.p.x plus equal this.p.speed. And this step is going to get called every single time we go through that loop. So now if we go ahead and run our application, and I hit the left or right buttons on the keyboard, you can see that the ship is moving around. Now notice I'm going off the screen. We need to fix that next, the same way we had done in our previous version of this game, where we had basically used a clamp to make sure that we stayed within these boundaries. Okay, so let's go ahead and add that clamp function that we had created before. We're going to just add the same type of thing here. We're going to say var clamp is equal to a function, and it's going to take an x, min, and a max. And then remember, we're just going to do return x is less than min, question mark, min, colon, and then we're going to say x is greater than max. We'll return max, or we'll do question mark, max, colon, x. Okay, so now we have a clamp function that we can utilize, and we're just going to utilize it right here. So after we try to move our player, if we end up going too far one direction, we'll bring him back. So what we're going to do is just say this.p.x is equal to clamp, and then we're going to do this.p.x. And then what we want to do here, for our minimum, it needs to be not just 0, but it needs to be 0 plus, and we're going to do this.p.w divided by 2. And the reason for that is because remember our x for our px on our player sprite is the center point of it. So we want to make sure that we're offset by half of that sprite. Otherwise, we'll let them go half off the screen, which we don't want. Then for the max part, we're going to do q.el.width. And again, we're just going to do a minus And this time we're going to do this.p.w divided by 2. So now we'll be basically clamping this x between that max and min value. So the player shouldn't be able to go off the screen. So now if we run this, I'm going to hold down the left button. And you can see I get stopped right here at the edge of the screen. I'm going to hold down right, and the same thing happens again. I get stopped there, so I can't go off of the screen. Okay, so the next thing that we're going to do now is we're going to convert this over. This update loop is okay, this game loop here, but the problem with it is that if we keep on adding different objects, we're going to have to call update and render on each one of them inside here. It would be nice if we could have this all managed for us and not have to worry so much about the game loop, to think more in terms of stages and adding things to stages. So we can do this. What we have to do is, instead of using our game loop, we're going to use what's called the scenes module. So in order to do that, we're just basically going to import this scenes. And then this will give us access to use stages. And the way that we do this is, first we declare a scene. And now a scene is going to define what is going to be present inside our game. We can actually have multiple scenes, and the scene is going to keep track of everything for us. So just like we define our sprites and our other game objects outside of our load, we're going to define our scene here. So we're going to say q.scene. And we're going to call this main level. And then we're going to pass a function that takes in a stage as a parameter. And inside here, we have to set up our scene. So one thing that we're going to do, first of all, is we're going to make sure that the gravity is set to 0, because we are doing a space shooter game. Now, this won't affect us too much at this point, but I always try to do this because it's easy to forget. And if you use the 2D module, then it's going to automatically add some gravity. In our case, it's not going to make much of a difference, so it won't really affect anything, but it is good to remember this. If you do use the 2D module and you automatically want to have gravity, you of course wouldn't put this in place, but in our case, we don't want to have gravity in space. The next thing we're going to do is stage.insert, and this is how we insert something to the stage. So first, let's do a new q.sprite, and then we're going to add our background. So actually, we can pretty much just copy this code here. So let's just grab this, and we will put it over here. And we don't need that semicolon. We can move it out there. Okay, so now we are basically inserting our sprite. We don't need that extra new. And that'll be for our background. Now this will return our sprite, so we can actually get an instance of it if we need to. In our case, we don't. And then the next thing we're going to do is stage.insert our player. So we'll do stage.insert, and then we'll add our player. So this is just a new q.player. And then anything else we wanted on our stage, we could insert there as well. So now what we can actually do is we can get rid of all of this code here, and we can replace this with just a simple call to q.stageScene, and then we can say what scene we want to stage. So we want to stage the main level. That's going to cause this main level to be activated, and this will basically make it so that anything that's inserted in here is automatically going to have its step called its update, basically, in its render. So it's going to update and render our background and our player, and everything should work just as it did before, except now we're using stages. So if I go ahead and run this, you'll notice also that these on-screen controls came up, and that's because they are only enabled when you're using the stages. And we can control our ship. You can see that we can go left and right, and we do still have that clamping. Now, these controls are a little bit big on the screen here. I'm going to show you a way that we can reduce those in a little bit here. And we're also going to enable touch. So let's go ahead and do that real quick. You'll notice that if I click on these with the mouse, it doesn't do anything at this point. But if I come out of here, and then we go up here, and then we add .touch, it's going to enable touch, which will give us touch control. Okay, so now that we've enabled touch, we won't be able to really demonstrate this with the mouse, but if you run this on a mobile device, you'd notice now that when you run this, that you'd be able to touch the screen and touch those buttons, and those buttons would respond. Okay, now you might have noticed that our controls on our screen look a little bit odd. They're a little bit too big. We can actually customize our controls. So the way that we can do this is instead of calling controls here, we're going to not call it yet. Instead, we're going to do q.input, and then we can do this touch controls. And then in here, we can pass in an object that's going to basically have options for our controls. So inside here, we can do controls, and then we can pass in this array that's going to define what is going to appear inside of that control. So we can make it so that we have first our left control, and then that's going to show a symbol that'll be this left arrow. Then we can have our right control, and we can show the right arrow. Let's make sure we have that closed out. And then I'm going to add a couple of blank ones here. If we add blank ones, what this will do is it will basically just resize those controls. So it's going to take up a blank space, and the controls will automatically size so that they're proportioned to the size of the screen. So the more of these we add, the smaller all of our controls will be. So I'm going to add 4 blank ones, which should get things pretty small here. And then at the other side of the screen, we're going to add fire, and we'll make this be A for the A button. So now what we need to do is actually call controls ourselves. So we're just going to do Q controls, and this will enable those controls. And now if we were to run this, what you should see on the screen now is some much smaller controls and just this A on this side. So now you can see when these controls are being pressed, and the space bar actually makes the A button get pressed here. So you could actually have whatever kind of control scheme that you want, and you can make these controls as small as you'd like. Okay, so now the next thing that we're going to do is we're actually going to create a shot sprite, because we're going to add the capability to shoot. But before we can shoot, we need to have a laser bullet that we're going to shoot. So we need a sprite for that. So the first thing we're going to do this is we're going to add a sprite sheet for our shot. I'm just going to copy this over. I've already created this one. So you can see that it has 4 frames of animation. This will animate nicely and look like a little pulsing shot. And then what we want to do is we want to create our actual sprite, and we want to load up this asset. So we'll need to also create a new copy of our data. Let's go ahead and do that real quick. And we're going to rename this one, and we're going to call this shot.json. And then what we're going to do here is let's go ahead and set this up to be correct for the shots. So this is going to be called shot, and then the tile W is going to be 13. The tile H is going to be 31 in our case. The SX and SY we're going to leave. The width is going to be double the tile W, so that'll be 26, and then the height will be 62. Okay, so now we are going to go back into our game, and we need to load up these assets. So let's go ahead and make it so that we load up that shot PNG. So we're going to do this shot.png, and then we're going to load up that JSON as well. So we're going to do shot.json. Okay, so now we're set, and we can actually create our shot sprite. Okay, so let's go ahead and create our shot sprite. So the way we're going to do this is going to be very similar to our player. We're just going to do a q.sprite. And again, make sure that you do sprite and not sprites, and then extend. And we're just going to say shot for the name of it. And then what we'll do here is in our init, we're just going to do the same thing that we did before for player. We're going to pass in p, and then we want to call this _super, and pass in our p as well. And then inside here, we're going to add our sprite, which we're going to call shot. And then we want to have our sheet, which is going to be shot as well. And then we're going to set up a few more defaults here. Let's set up our speed. And we're going to set this equal to 200. And then we're also going to want to add some animation to this. So let's go ahead and do that. We need to add another animation just like we did for the player. So we're going to add one right here. We're just going to call this one shot. And that'll work just like we did for the player. We also need to compile this sprite sheet here. So we're just going to say shot.png goes with shot.json. Now, all we have to do is come inside of our sprite, and we are just going to do this.add. We're going to add animation, and then we're going to do this.play, and we're going to play default. Okay, so now we'll have an animated shot sprite, and let's just go ahead and throw this onto the screen just to see what this looks like. It's not going to be moving yet, but let's just make sure that everything is correct and our sprite will display. So we're just going to do insert, we're going to do new q.shot, and then here we're going to, let's just set our x to 100 and our y to 100. So we should be able to see this on the screen. So let's go ahead and run this. Now you can see there's a shot right there. It's just hovering in place and animating. And now we need to actually make this fire from our spaceship. So in order to do that, we're actually going to be creating a gun component that's going to be able to fire these shots and keep track of them. Now, one thing that I really like about Quintus is the ability to use what's called components. So in Quintus, we can basically create something like, in our case, we're going to create a gun, and we're going to give that component some attributes like the ability to shoot, and it's going to control how the shooting happens. And what we can do is we can basically take this component and we can add it to a sprite. So we're already using some components so far. For example, we're using animation, which is giving our sprite the ability to do animation. And then once we have added that animation component, we can just call play and then play an animation. We're going to be using a similar technique to make a gun that's going to give our sprite the ability to fire. In fact, we're automatically going to handle all of the firing capabilities that a sprite needs in our component itself. This is really useful, and you'll see how this will work in the next module when we actually take the same gun and we adapt it to the enemy, and we don't have to write specific code for the enemy sprite that handles firing. Okay, so let's go ahead and add our component. I'm just going to add this below our shot definition. Here, I'm just going to do a q.component, and then we're going to pass the name of the component, which we're going to call this one gun. And then inside here, we can do a couple of interesting things. We can basically execute some code when the component is added to a sprite, which is going to give it the ability to add some properties to that sprite. So we can initialize things, we can give the sprite some new attributes, some new properties that we can later utilize. And then we can also extend, which is going to add some new functionality to the sprite itself. So let's go ahead and first add our added. So if we add this added, what's going to happen is this function is going to execute as soon as this component is added. And then we can access inside here our actual entity, the sprite that we're using or that we're adding this component to, and then we can do something with this. So in our case, what we want to do is let's do this.entity, and that's going to give us that entity, and then we're going to do p. Remember, all of the properties exist under p on a sprite, and we're going to add shots, and we're just going to make this be equal to an array. So we're just going to have a blank array. This is where we're going to store all the shots that the sprite has fired at this point, so it can keep track of them. Then the next thing that we're going to do is we're going to add the ability to shoot. So let's go ahead and format this real quick. And then we're going to add a comma here, and we're going to add this extend. Now in extend, we can add any kind of new functionality we want that's going to be applied to whoever adds this component. So let's do this fire. Okay, so now they're going to have a fire function, and we're going to go ahead and create our fire function. And we'll just do a simple implementation for now. And the way that we're going to do this is we're just going to say if q.inputs, and remember we have these commands here, so we're going to check for fire. So if it's time to fire, if they've hit the fire button, then what we want to do is to go ahead and create a new shot. So let's go ahead and do that. But what I'm going to do here is I'm going to get our entity, and I'm going to store it in a variable so that it'll be a little bit easier for us to utilize this. It's actually going to be this, but since we're writing this code inside this component, I like to do this so I remember that it's the entity. This is sort of confusing in JavaScript, so remember this is actually a function that's going to be added to the sprite that we add this component to. So this makes things a little bit more clear. So we're using our entity. Now what I'm going to do here is I'm going to create a shot, and let's just make the shot equal to, we'll do q.stage. Remember, we want to add this shot to the actual stage, and we're going to do insert, and then we want to do a new q.shot, and then let's fix that. The IntelliSense sometimes will mess us up a little bit. And then we want to give the properties for this. So let's say that the x position will be this.p.x. So we want to start the shot where the center of the ship is. That'll be the center of the shot. And then our y position is going to be this.p.y. And we'll do a -50 on this just to position it a little bit above the ship. You'll have to play around with whatever sprite you're using to make it line up to where on the sprite it should shoot. Then we're going to set the speed equal to 200, even though it already defaults to 200. You'll see why a little bit later when we have an enemy ship that's actually going to default to a different speed. And then we're going to set the type on this. We're not going to really use this at this point, but let's go ahead and make this type be sprite default. This is the default all sprites, and then we're going to OR this to q.sprite friendly. So this is a friendly shot that we're shooting, and we'll use this a little bit later when we actually determine whether a shot is a friendly or an enemy shot. But for now, that will work. And what we want to do inside here is, let's go ahead and expand this out a little bit. We are going to want to store our shot. So right now we've added our shot to the screen, but we need to put this into our array. So we're just going to do this.p.shots. And here we could actually use entity. So let's just go ahead and do that. That'll make things easier. Entity.p.shots. And then we're going to do push and push this shot onto the array. Now you might have also noticed that we can use entity here. Remember, we're writing this in the context of that sprite that we're going to attach this to. So it makes sense to do entity in all these places. It's sort of up to you if you want to use entity or if you want to just use this and remember what this represents. I tend to like to use entity in this case. So now we have our shot on our array, so we're keeping track of it. We're not doing any kind of cleanup or anything at this point, but what we should be able to do now is we can call fire on our sprite when we add it. So if we go to our player now, let's go ahead and do this.add, and we're going to add a gun. So it has this gun component. And then every step here, we're going to check for firing, so we're just going to call this.fire, and we'll now have this firing functionality because we have our gun. So let's go ahead and restart this and see what this looks like. So we've still got our shot hanging out in space there. We'll have to fix that in a little bit. I'm going to hit the space bar, and you can see that my shot is appearing. Now we have to give our shot some ability to move, but I'm generating these shots now. So we're able to fire by hitting the space bar, and if you're on touch, you can always touch that A there and it will do a firing. So now what we're going to want to do is get rid of this one hanging around and then make these ones move once they are in the game. Okay, so let's go ahead and get rid of that shot that was hanging around. We don't really need that anymore. And let's now make it so that shots know how to move. So the way that we're going to make shots move is slightly similar to the way that we're using the step on our player. What we want to do is we're going to create a step for this, and we're basically going to have a shot update its location on every step. So we're going to add our step here. Remember, this is going to get executed every single time that that update occurs in our update loop. And then what we're going to do here is we're just going to do this.p.y minus equals this.p.speed times dt. So let me explain why we're doing it this way. So first of all, our y location is going to be at the bottom of the screen right now. We're only worrying about player shots right now. So our y is going to be a high value, right? Because it's near the bottom. every time that we have this tick happen, this step, we're going to minus from that whatever our speed is. But we need to multiply it by this dt because this could be executed at different intervals. So we're sort of saying, okay, if the speed is 200 whatevers per second, or it doesn't really matter what the actual speed is per se, what we care about is that this is actually happening in the correct amount of time. So this dt is telling us how much time has passed, so we're multiplying it by that amount of time. So for example, let's say our dt was 0.5. That would be half of our speed because half a second has passed. And let's say our dt was 1, then it would be our full speed because 1 second was passed. So this is going to make things uniform for us, not dependent on how quickly this updates, which on a different processor, maybe this loop would be functioning a little bit faster, so you would have some kind of weird behavior depending on what platform you're running on, which we don't want. Okay, so now we're going to end up moving our shot, and then later on, we're going to handle destroying our shots inside here, but let's just go ahead and check this out and see if our shots will now move. So we've got our game here, and I'm going to fire shots, and you can see we're getting some rapid shots here. We're going to have to fix that a little bit later, unless you like that. That's kind of cool. But you can see that the shots are now moving up here, and here's something interesting. So remember, we're not actually doing any cleanup here, so we're going to have a little bit of an issue if we do this, and I'll show you real quick what a selector looks like inside of Quintus. So we can do Q, and then we can select a type of sprite. So in this case, it's a player sprite. And then, so that's going to get all the players, and we can do .first, just kind of like jQuery. So that's going to give our first player. And then we can do .p, get our property. And then here, remember, we have the shots. It's an array that has 184 items in it, each one of these shots. So we're going to have to do some cleanup when these shots go off of the screen. Okay, so now before we move on, we're going to do a little bit of refactoring here. I don't know about you, but I really don't like the idea that this player has to call fire on here because it's kind of weird. Like, the player doesn't really know about firing. It's having this added to it, and you can use this. This is fine, but the problem with this is you have to know that when you add a gun component, it requires you to call fire within the step in order to be able to fire. What I'd like to do instead is just get rid of this and say, okay, if we add this gun component, the gun adds that capability for us, so it will just work. We don't have to add anything to our player in addition. And we can actually do this, and the way that we do this is using the event model inside of Quintus. This is a pretty neat piece of functionality. So what we can do in Quintus is inside our added, we can basically say this.entity.on, and we're going to basically subscribe to an event. We're going to say on step. So whenever step is going to happen every time that update cycle goes through, we're going to have this call a method called handle firing. And we're going to add this method to our class. So under here, let's go ahead and add another function to this. So we're just going to add this function that's going to be called handle firing. And we'll just make this be a function that takes dt, because we're actually going to get dt from this event since it does pass that in. Now what we'll do here is let's go ahead and put our if logic inside there. So we're going to move this over here, and we'll say, okay, so if they hit the fire button, then let's do a this.fire, and we'll go ahead and actually call fire, and let's add our comma here. Okay, so then in fire, we're assuming that, yes, you can fire if you got here. So we can get rid of some of this. Let's format this. Okay, so now everything is going to be pretty much automatic. If we add gun to something, it's going to be able to shoot based on the input. So now if we were to run this again, we should get the behavior we're looking for. It works just like it did before, except now we've made this a little bit more compartmentalized into that gun component. So now that gun component is going to be a little bit more reusable. Okay, so we still have a bit of an issue here, which is that our shots are basically just growing and growing as we continue to shoot, and they're never getting cleaned up. And this is important because we'll eventually run out of memory, and it's just not a good idea to leave all these objects lying around. If we have to loop through them, it's going to take longer to loop through them. We should be cleaning these shots up. So what we want to do is we really want to check to see if a shot goes off the screen, we don't really need it anymore. So that's a good cue to get rid of it. So let's make it so that shots know how to destroy themselves, and then we'll later remove them from the array. So the first thing that we're going to do is inside our shot, inside our step, we're going to go ahead and make it so that a shot can figure out if it needs to be removed. We're going to do if this dot p dot y is greater than q dot el dot height. So if it's past the top of the screen or the bottom of the screen in this case, then we don't need it. Or if this dot p dot y is less than 0. So if it's less than 0, also it's off the screen. We're just going to call this destroy, which is going to actually destroy our sprite. Now this is going to make it disappear, but it's not going to remove it from our array. So that responsibility really belongs inside of the gun. So we're going to go ahead and add that functionality. We're going to put this in our handle firing. And since we're going to be adding some more to the handle firing, I'm just going to make that entity to make things a little bit more clear for me. So I'm just going to say entity equals this, just to remember that. And then I'm going to do a loop here. So I'm going to say for var I equals entity.p.shots.length -1. So we're going to start from the end, and we're going to do I greater than equal to 0, and then I minus minus. Okay, so what we're going to do in here is we're just going to say if entity.p.shots I is destroyed. So if it's destroyed, then we're going to remove it from our array. So we're going to do that with an entity.p.shots.splice. And this splice, we're going to specify I and 1. That will just remove that element from that array and basically collapse that array down. So since we're counting backwards, this should be fine. We shouldn't have a problem by removing things in the array because we're always removing it from the end, which is always going to be safe. Very important when you're removing things from arrays or lists to keep that in mind. So now what we're going to do at this point is we're going to add a little bit of logging here just to be able to track this. So every time that we fire a shot, let's do a console.log, and we're going to do entity.p.shots. So we'll see what shots we have. In fact, we can convert this to entity now. And then every time we remove a shot, let's just say console.log removed shot. Now let's go ahead and run our game. And let's see what this looks like. So we'll open up our JavaScript console. And now I'm going to shoot. And you can see that those shots are building up. And then those shots get removed. So now if I do just one shot, you can see there's just one in there. So here we go. Lots of shots. And then all these shots are getting removed. And this is a good way, especially when you're doing some game development to debug, is to do something like this where you're using the console log. So you don't have to guess about this. It makes it really easy to figure out what's going on here. Let's go ahead and remove those logging so we don't forget that since we have this working now. So we'll get rid of this one. And we will get rid of this one. Okay, so now the only thing that really remains is to throttle our shots. We don't want to be able to shoot so often. So there's a few different ways that you can use to throttle shots in games. I've done a few different techniques. What I really like about JavaScript is that it's pretty easy to do something like set a timeout. So we can use that functionality to make it so that our shots are throttled. So here's the basic strategy that we're going to be doing here. We're going to hold a variable that's going to say whether or not the player or whoever's using the gun essentially can fire a shot. And this is going to default to true. Then what we'll do is every time that a shot is fired, we will say that they can't fire anymore. We'll set a timeout for, let's say, half a second. And then when that timeout comes back, it's going to set can fire to true. So then they'll actually be able to shoot again. And we'll just make it so that every time that we fire a shot, we'll check to make sure that they can actually fire. This will effectively throttle our shots. So let's go ahead and inside of our gun, we should put this behavior in here because the gun should really handle this throttling of shots. We're going to do this.entity.p.canFire, and we're going to set this equal to true. So now we have this variable that we're going to use, and then inside here, when we try to do our fire, we want to check to see if they can actually fire. So we're just going to make this real simple. We're just going to say if not, in fact, let's put our entity up here. If not, entity.p.shots p.canFire. So if they can't fire, hey, just return. We're done. We don't need to do anything else. We'll skip that. Now, if they do fire, what we want to do is we're going to, first off, I'll set the canFire to false. So we're going to say entity.p.canFire. And this is now equal to false. Okay, then the next thing we want to do is called a set timeout. This is just a JavaScript function that will set a timeout. So we're going to basically say, okay, after 500 milliseconds, then do what's in here. Call this function. And inside our function, all we're going to do is we're just going to say entity.p.canFire equals true. So now what's going to happen here is that if someone fires, it's going to basically set canFire to false. Then if they try to fire again before this timer has gone off, it's going to just reject. It's just going to return out of here. So effectively, if we run this now, we should have throttling in place. So if we try to fire, you can see I'm hitting, you can hear me hitting the space bar a bunch of times, and I'm only firing at the pace that I'm allowed to fire. And we're doing this in a very reactive way by using the timer. I really like this approach because we don't have to constantly do checking and we don't have to store time. We're basically just saying, hey, call back in half a second and then set this variable to true, and then we can fire again. All right, so we're actually getting some pretty nice functionality in our game at this point. We can move around, we make sure that we stay in bounds, we can shoot, we clean up after ourselves for the shots, and we figured out how to throttle the shots, but our game really is lacking something. It's not much fun to play if we don't have an enemy to kill. So coming up next in the next module, I'll be showing you how to add an enemy, which is going to be similar to what we've done so far, but we're also going to make it so that the enemy has some AI using component, and we're going to reuse some of the gun component logic, and then we're also going to be dealing with collisions. What happens when an enemy is shot or a player is shot? We need to destroy the shot and destroy the enemy or player. So all that will be coming up in the next module. Thanks for joining me, and take care.